Okay, the next one is determination of KLA values. Okay, the how to determine the KLA. Okay, the first method is oxygen balance method. In this method, the oxygen content of the gas stream flowing to and from the fermenter are measured. That is from the inlet and the outlet it will get measured. So Na is equal to 1 by VL, that is Fg, that is the volumetric gas coefficient, and Ch is a concentration of gas in gas phase. Okay, I is the inlet, and here Fg, Cag, that is a concentration in gas. O is the outlet. So Na is the mass transfer of the particular content. Vl is the volume of the liquid in the fermenter. Fg is the volumetric gas flow rate. Ca is the gas phase concentration of the oxygen. Subscripts I and O refers the inlet and the outlet of the gas streams. The first term in the right hand side represents the rate at which the oxygen enters into the fermenter and the inlet, and how much amount of oxygen leaves into outlet. Okay, that gas concentration is generally measured as a partial pressures, okay, by means of ideal gas law. What is the expression is Na is equal to 1 by RVL Fg Pag by T minus Fg Pag by T. The same expression, it will be ideal in a partial pressure, that is by ideal gas law. So Pag is the oxygen partial pressure in the gas, T is the absolute temperature. So this oxygen balance method is a steady state oxygen balance. It's mainly used to determine the KLA values. Another method one is a dynamic method. This is the unsteady state mass balance for oxygen. Okay, this is unsteady. Here in this graph, you see in this graph, x-axis refers time and the y-axis is that is concentration of the liquid in the bulk phase. Here you see the air is off. So in the graph you see the air is off means, and the particular time air is off. Here the oxygen is off condition, while air is on, and the particular time the oxygen is on means if the cells need some oxygen, right? If the cells have deprived of oxygen, depleted of oxygen means it will go here C critical. C critical is depleted of oxygen. Cells needs some oxygen, but it get depleted. The cells doesn't get any oxygen, so it will goes on to C critical stage. So we don't allow them to go to C critical stage. Okay, so we have to on the particular oxygen system. If you are on the oxygen system means now the air enters into, that is oxygen enters into the fermenter. The cells get utilizes your oxygen. So now the graph will be going and then to its steady state. Okay, steadily the oxygen enters into the cells. It will reach a steady state, that is a CAL. So this is the two differences. The CAL1 is the initial oxygen, CAL2 is your final oxygen and reaches the particular. Then after that it will enter into the steady state. So this is the dynamic method. So this will be described here in the further slides. After that we have an expression, that is dCal by dt is equal to KLA CAL star minus CAL minus Q naught x. That is dCal by dt. That is how much amount of oxygen enters into the liquid phase at the particular time. Okay, that is equal to the mass transfer coefficient, difference of your liquid concentration of the liquid and the uptake of the cells. At a steady state, dCal by dt is equal to 0 means you have to substitute in that equation 0. We get we can easily find out the Q naught x, that is the cells uptake by the cells. Q naught x is equal to KLA CAL star minus CAL bar. So from that we get expression KLA is equal to ln CAL bar minus CAL1 divided by CAL bar minus CAL2 divided by T2 minus T1. From that graph we can easily determine the slope KLA. This is the dynamic method. We have seen two method for KLA determination. What is this? Oxygen balance method. Another one is dynamic method. Last and final method for KLA determination is sulfide oxidation method. It's mainly based on the oxidation of sodium sulfite to the sulfate in the presence of catalysts such as copper. Although the sulfide method is most widely used, it will depends on the operating conditions. Higher KLA values. Okay, it will give a higher KLA values compared to other two techniques. Okay, so that is the main difference compared to the other two techniques. Okay, in the other two techniques, what? Oxygen balance method and dynamic method. Compared to these two techniques, sulfate oxidation technique gives you higher KLa values. Okay, there is a main difference here. Based on the oxidation of sodium sulfide to sulfate in the presence of catalysts such as copper. Okay, that's all. So today we have seen what all we have seen: the oxygen mass transfer in bioreactors, how the oxygen enters into the fermenter, how the cells takes this oxygen and utilizes this oxygen and for their further metabolism of these cells, and how the oxygen delivers into the cells. How will it get delivered? Through the spargel diffusers, like that it will delivers. Then how to determine the KLa value. There are three determination methods. One is oxygen balance method, dynamic method, sulfide method. Oxygen balance is the steady state oxygen method. This is dynamic method is a unsteady state mass balance method, and the last method is sulfide oxidation method. So important question is the determination of KLa values, and what are the three methods. These are very important question in for your exam. And also the oxygen mass transfer in bioreactors is also very much important question for your exam. You can draw the particular first picture now. You can draw this oxygen mass transfer, then you have to describe what are the points regarding in this oxygen mass transfer. You get a good marks in your exams. Okay, study well, students. I will continue if further important questions arises means I will continue. If you are asking any doubts means you can raise the questions in your Google Classroom. I will clear the doubts. Okay, thank you students. Stay home safely. Okay, bye students.